So the MCQs on this partial differential equation that we are going to see today. Just a minute. So the first one is regarding order and degree of differential equation, and yes, to remember this, the sentence is written, okay, साहित्य written there, जिसका order उसका degree. Okay, that's good. These are shortcuts for some sentences that you can use it to remember how to get a degree and the order of a differential equation. So the order of differential equation is nothing but it is a highest order differential coefficient present. So if you observe the differential coefficient, this is the second order differential coefficient, this is the first order, and this is again a first order. So highest order differential coefficient present is a 2, so the order is 2. So we get order first. That order is the highest order differential coefficient. Highest order differential coefficient. That is the order. And then the power of that highest order differential coefficient is a degree. Now dou 2z by dou x square raised to nothing is written. That means there is a raised to 1, and that becomes a degree. So degree is 1 and the order is 2, and that's written correctly. So it's a second order differential equation and first degree differential equation. Okay, so that way we write order and degree there. Now the second question, we want the complementary function for this second order differential equation. We already know to get the CF, just we put d equal to m and d dash by 1. If we put d by m and d dash by 1 and we get the roots of auxiliary equation, then f of y plus mx. F of y plus mx is the CF here, and it is a repeated root. 2 is a repeated root, so f1y plus 2x plus x times f2 of y plus 2x, that is the CF. That's the correct answer again. Okay, so getting the root of quadratic and cubic equation is very important for you, because not only in PDE, we already seen that in LD also we require the roots of this quadratic and cubic equation. And once we get a root, depending on the situation, we can write the complementary function. Is that? Okay, so question number 3 now, we want the solution for dou 2z by dou y square equal to sine of xy. Now, no method required. Yes, it is on direct integration, because you observe it is a differential coefficient is equal to function of xy given. Just we integrate this equation 2 times with respect to y and we get answer. So integrating this differential equation with respect to y, this dou 2z by dou y square remains only dou z by dou y, and integration of sine is a minus cos xy upon x. That's correct, because we have treated x like a constant, and the constant of integration taken as f1x. Again integrated with respect to y, and the integration is here, and yes, it's written correctly. Okay, so the answer is correct again. If anyone have a doubt, yes, you can ask. So that about the third question. Okay. So it is on direct integration. Question number 4. The question will be what is the solution for this differential equation? First, the identification is important. It is like PP plus QQ equal to R form. This one. This is known as a Lagrange's form. So in Lagrange's form, we get a solution by Lagrange's auxiliary equation. So it is written the Lagrange's auxiliary equation, dx upon capital P equal to dy upon capital Q is equal to dz upon capital R. And now to get a solution, we require first of all, we require two solutions from this auxiliary equation, and using that we can write the solution for that differential equation. So first thing that he observed, that is a dx plus dy plus dz. If you add this, means indirectly we take 1 1 1 as a multiplier. So whenever the sum of a denominator is a 0, as sum of denominator is 0, by theorem of equal ratio, the sum of a numerator should be 0. So dx plus dy plus dz should equal to the 0, and so integration, that is x plus y plus z is equal to c. So the first solution he written correctly, that is x plus y plus z is a constant. Now one more solution we have to find out. It's not direct integration possible, so I think you observed x y z also the multiplier. So if we multiply x y z to the denominators and we add it, you can see here, if we multiply by x to the first, multiply y with the second, and multiply z to the third, we get xy minus xz plus yz minus xy plus xz and minus yz. We observe yz gets cancelled, plus xz minus xz and plus xy. So yes, again the sum of denominator is coming 0. So just you can write it. This is just a cross checking. No need to write this sahitya. What you can do it. You can say as a 111 r multiplier. This implies dx plus dy plus dz is a 0, and then you can say integrating x plus y plus z equal to constant c1. So this one solution you are written. Also xyz are multipliers. The meaning of multipliers are generally they gives us the denominator 0. So this gives us x dx plus y dy plus z dz should be 0, and we can say x square plus y square plus z square, actually x square by 2 plus y square by 2 plus z square by 2 is equal to c2. I will take c2 dash first, and then I take that 2 also on the other side. So x square plus y square plus z square is equal to c2, and that's another solution. Good. So that about two solutions, and when we have two solutions, we can write the final answer in two different ways. One way is a function of u comma v equal to 0, and the other way is a u is equal to phi of v. Both are the way of writing the solution. Both are correct. So phi of u comma v equal to 0 means phi of x. So your answer may be this one, phi of x plus y plus z comma x square plus y square plus z square equal to 0, or that x plus y plus z is equal to phi of x square plus y square plus z square. These are the different ways. So if you have the doubt, you can ask here. If you have the doubt, because there are different ways of writing. How he written? Yes, he written phi of u comma v equal to 0 form, and that's correct. This is one of the way. But if the options are available and in the options this form is not given, instead you are given x plus y plus z is equal to phi of x square plus y square plus z square. That is also the way. Instead of phi, some author can use f. F has a function. So this phi, this is just a notation for the function. We can use any notation for denoting the function there. That's one. Any doubt in the first four questions? No. So the fifth one, we want pi for sine of x plus 1, and we know the method. The method is here written, that is replace d square by minus a square, dd dash by minus ab, and d dash square by minus b square. In this case, denominator doesn't contain d dash square term, so just we replace d square by minus 1 and dd dash by minus 1, and this is the correct answer. This one is the correct answer. Yes, that's the way of writing a pi. So questions are not so difficult, but the important thing, you should click these things. You should know quickly what is the replacement and how you can complete it. So that is the main part. So question number 6. The partial differential equation obtained by two arbitrary constant. When we eliminate two arbitrary constant, we get first order PDE. Okay, remember, when we eliminate two arbitrary constant or one arbitrary function, we get first order PDE. But when we eliminate two arbitrary function, we get second order PDE. Okay, is that? So just to eliminate it, if you take dou z by dou x, we get as a, and dou z by dou y as a b. So it is very simple and straightforward. We get this is the PDE. Any doubt? This is the PDE corresponding to the given solution, which is z equal to ax plus by plus ab. So where we have replaced p by a and q by b, we get a solution. This is actually the first form of a first order PDE. We see that f of pq equal to 0. F of pq equal to 0. Okay, so both way you can go. From solution you can go to the from solution you can come to the differential equation, or from differential equation you can go to the solution. 7th, we have to solve root p plus root q equal to 1. Yes, it is f of pq again, that is the form. So we get the relation between a and b. Very nice. You got a in terms of b, and z equal to ax plus by plus c is always a solution where either we have to replace the value of a or we have to replace the value of b. In this case, Sahitya replace the value of a and we get the solution in terms of b and c. Okay, so final answer should contain only two arbitrary constant because it is a solution representing the first order PDE. Okay, so because of that, the answer is in two constant b and c there. Good. Next, p root x plus q root y, and very straightforward. You quickly observe it is in Lagrange's form. Pp plus qq equal to r. Axial equation. Yes, now from first two ratio, one solution, from last two ratio, another solution can be taken. But here, Sahitya taken first and last ratio. So multiple answers are there. One of the answer, what he written, that's correct again. Okay. So this is a phi of u comma v equal to 0 written. So you can write u equal to phi of v also. Ninth, again it is in a Lagrange's form. P minus q is equal to log of x plus y. So pp plus qq equal to r. That form is taken. So from first two ratio we got one answer. But here now this is one most important thing. This question may be first time you came across. Whatever the constant we get from the first solution x plus y equal to c, yes, you can replace it here. You can replace that as a c there and dx upon 1, and now you can take either first and last ratio or second and last ratio. Okay, so that way you get, so this way you get the dx upon 1 upon dz upon log c. Why it is log c? Because x plus y is c we already got from one solution. So one solution can be used to solve the other here, and this way he completed it and again resubstituted the value of c, and whatever the answer he written, that's again correct there. Good, very good, Saitya. So phi of x plus y and x log of x plus y minus z equal to 0. So that about the first 9 question. If anyone have a doubt in first 9 question, yes, you can ask. Is there any doubt in the first 9 question? No doubt. Okay, Aryan, good. Okay, thank you. Okay, so come to the next then. Now we are moving from 10 to 18 now. I think Neil completed this. So the order of the differential equation by eliminating arbitrary function f. So how many functions are there? Only one arbitrary function. So when we eliminate one arbitrary function, we get a first order PDE, and that's correct. So the answer is first order PDE. Yes, it is correct. So if we eliminate two arbitrary function, we get a second order PDE there. Okay, you should know that. Now the solution for x dou z by dou x equal to 2x plus y is, now you will observe only one differential coefficient is there, so it is just by direct integration. This is not any method you have to apply, not pq form, pqz form or any other, just dou z by dou x is there. So x is taken on the RHS, x dou z by dou x is 2x plus y. So okay, it is integrated with respect to x, but here what is done with this x? Yes, Neil, what you completed? What about that x? X is removed direct, or there are two ways. Okay, actually I think he not written that way. So this can be written as this dou z by dou x is equal to 2x plus y divided by x, and if you take separate division, it's a 2 plus y by x, and now we are integrating with x. So integration of dou z by dou x is z, that's correct. Integration of 2 is with respect to x is 2x, that is also correct. Integration of y by x is y log x, and the constant of integration is f1y. Now it is correct. Okay, so this term integrated. So just x is taken on the RHS there. Okay, that's correct answer. Any doubt? No. Question number 12. By eliminating a and b, we have to form the PDE now. So yes, this is a general form ax plus by. So when we take dou z by dou x, we get a, and when we take dou z by dou y, that is also a. So we get p is equal to q. So p is equal to q is the answer. Very simple. You'll observe, you'll take dou z by dou x, you get a. Dou z by dou y is also a. So obviously you get the equation. If you find the relation between them, so p is equal to q. So the differential equation is here. This is the answer. P equal to q. This is the differential equation corresponding to, you can write it in the form of PQ, or you can write it in, okay. So any doubt here? No. 13th, the solution for d cube minus 3d square. Okay, this is the third order PDE, but you'll observe this is you have to find out the roots of auxiliary equation. Once we get root as a 0, 2 and 1, so f of y plus mx, so f1 of y plus mx, m is a 0, so f1 of y plus f2 of y plus, and this is the correct answer. Okay, just you have to get the roots of the auxiliary equation there. Good. Okay, nice step by step completed, Neil. Good. Now by eliminating the arbitrary constant, the differential equation we want. So how many constants we have here? A and B again. So to eliminate the two arbitrary constant, we get first order PDE. But let me see here. Dou z by dou x is coming a square, and dou z by dou y is coming as dou z by dou y is a 2ay, correct? 2ay. And now we have p is equal to a square, q square equal to 4a square y square, and now you have to check the relation between them. So you get q square equal to, this a square can be replaced as a p, and that's the correct answer. Nice. Okay, so this is the this is the important part, that you should think in that direction. Okay, this is the correct answer there. Good. A solution of uxy equal to 0 is of the form dou to u by dou x dou y, correct? This is the another notation. This is another notation. U of xy is written this way. That's correct here. So we have to integrate with respect to. So now this is the important part. Whether you will integrate with x first or y first. So whatever the written by Neil, is it correct? Is it correct? Yes, anyone? Whether you have to integrate it with respect to x first or y first. And the written by Neil is correct actually. Yes, not y. It is first x only. When you differentiate, see, outer operator is a dou by dou x now. We have to remove that first. To remove outer operator, dou by dou x, so we should integrate first with x only. Okay, that's written correctly. So we read dou u by dou y. As we are integrating with x, a function of y is a constant, and that's written correct again here. Now we integrate with y, and this is the answer. Yes, good. The solution of that uxy equal to 0 is in this form. Okay, will be in this form. 16th, then u is equal to x square plus t square is there, is a solution of this differential. Then c is, okay, you have to replace these values then. Yes, dou u by dou x is calculated, dou to u by dou x square calculated, similarly dou to u by dou t square calculated, and you will observe we get dou to u by dou x square equal to dou to u by dou t square. And now if you compare with original equation, c will be 1. So the answer c will be 1. That's good, correct. Any doubt? Comparing with the original equation, this is one equation we derived. This is the equation we derived, but we are given dou to u by dou x square equal to c times dou to u by dou t square, something like that. So obviously c will be 1. 17th, uxy equal to xy. Okay, we have to solve it. So dou to u by dou x dou y is xy. So first we have to integrate it with x. So that's written correct. And again we integrate with y now, and that is also correct. So this is the answer. Very good. Very good, Neil. Okay. And lastly, the CF for r minus 7s plus 60. So d square minus 7dd dash. Yes, this is the differential equation, the auxiliary equation. We can put d equal to m d dash by 1. And we get, this is the quadratic equation, m square minus 7m plus 6, and the roots 1 and 6, and this is the answer. Good. Okay. So I think yes, all the answers are correct. Nicely completed. Yes, I think Sahitya, Neil, both of yes we discussed. Any doubt in the first 18 questions? Anyone? Is there any doubt in the first 18 questions? Okay, so if not, then okay, so we are moving here on the 19th now. It is solved by Asif. Okay, so 19th question is xp plus yq equal to z, and we want a solution for this. Which form this one? You'll observe pp plus qq equal to r. pp plus qq equal to r. So you have to solve it by Lagrange's equation. You have to solve it by Lagrange's equation, and the answer, direct answer is written here. Or you can cross check if you want. So this is the answer here written. That is option 4, option number 4. So this is by the Lagrange's auxiliary equation. I'm not going in the detail now. I know that all you can solve now is 20th. This is again pp plus qq equal to r. Again the Lagrange's PDE, and he again Asif again given this correct answer only, that is third. This is the answer that is given. Now see the form, see the difference now. The previous answer, if you see this question, it is given f of u comma v equal to 0 form. F of u comma v equal to 0 form. And here the answer is given f of u equal to v form. F of u equal to v form, or u equal to f of v form. So you have to check, answer can be given in any of the one form. You should just tick the correct one. Okay, just tick the correct one. So third is correct here. Any doubt? I think yes, here he given the detailed solution now. Solved it and given that answer. Okay. So yes, here is the corrected answer. Okay. 21. The PDE of z equal to x plus y bracket square plus y is. So we have to eliminate the arbitrary constant c, and we should write the corresponding PDE. So if you observe, just if you take dou z by dou x, if you take dou z by dou x, we have 2 times c plus x. 2 times c plus x. Which one, Aryan, you want to solve? You want to see? 21? Yes, it is so simple. It is one of the simple questions. Let I show you. So this is the equation we are given. If we differentiate it with respect to x, we get dou z by dou x is equal to 2 times c plus x. As we are differentiating partially with x, derivative of y is 0. So indirectly we get the value of c plus x. What is the value of c plus x? This gives us c plus x is equal to dou z by dou x is p, so I will say p by 2. So if you replace now, if you replace this value of c plus x in the given equation, we get the answer. What is the answer? Z equal to what is the c plus x? It is a p. So it is a p square by 4 plus y, and that is the answer. Okay, and this is the answer then. Are you getting? So Aryan, is it clear? Okay, so just you have to think on the problem, you will get it. It's not difficult. Now next question is p plus q equal to z. So which form? Which form? P plus q equal to z. This is again the Lagrange's form. pp plus qq equal to r. So you have to take dx upon 1 equal to dy upon 1 is equal to dz by z. And you can get the two answers there. So I think he written directly the correct answer again here. So if anyone have a doubt, I will solve it. Otherwise, this is the answer. Anyone have a doubt in the 22nd? You have to solve this auxiliary equation. Dx upon 1, dy upon 1, dz upon z. This is the auxiliary equation that you have to solve it. Any doubt? No. So it is by Lagrange's auxiliary equation. 23rd. Okay, 2d square minus 3d dash plus d dash square, and we want a pi. It's not for CF, it is a pi. So, and RHS exponential function. So what we do it, we generally replace d square by minus a square, dd dash by minus ab, and d dash square is by minus b square. But if denominator comes to 0, if denominator comes to 0, so your answer will be different there. So you can check this question. If you replace d square by minus a square, means you get minus 2. Dd dash by minus ab, that is a minus 2, so it is plus 6, and d dash square is by minus b square, so it is a minus 4, so it is coming 0. Okay, so f of dd dash is coming 0 when we replace that d square by minus a square, dd dash by minus ab, and d dash square by minus b square. So direct method fails, so only the best method is actually now that general method. That way you can calculate, or only for exponential you can go this way also. We know to write that zp, we are multiplying by x and differentiate the denominator. Now differentiate the denominator, as we are multiplying by x, we should differentiate the denominator with respect to d only. So derivative of 2d square is a 4d. I'm saying it is only for exponential, not for trigonometry. Minus 3d dash, and this d dash square will become as we are differentiating partially with respect to d. I think, is it 0? Yes, if you have the problem, yes, you can go there, and not an issue. And e raised to x plus 2y. Yes, you want to take vaccination, you can go. So now you replace d by, let me check. If you replace d by a, that is 4, but there is a problem. We have, yes, we replace d by a and d dash by, no. You have to rationalize and you have to proceed. So better we use that general method only. We discussed that earlier. So go that way, and your answer will come. Y multiplied by x, because the denominator coming 0, and this is the answer. You will get it. If you want, we can solve it by general method. But we have tried just the factors and we have to proceed. We've done it actually. Yes, it is correct, Asif. Yes, I know it is correct. Yes, that's the correct answer. But only the method that I'm saying, which method you can get it to get that answer. Okay, so that way it is correct. Okay, so when we replace d by a and d dash by b there. Okay, you can check that way also. 24th now. 24th. It is a third order differential equation. Dou cube z by dou x cube equal to 0, and we have to solve. Just this equation we have to integrate 3 times with respect to x. But when we integrate with respect to x, treat f of other function as a constant there. And here is the answer written. That option 4 is correct. If anyone have a doubt, yes, you can ask. 3 times integrated this with respect to x only. Okay, 25th. Now the pi for d square minus d dash square is equal to cos of x plus y. Now for this we want a pi, so just go for zp equal to 1 upon d square minus d dash square, and then replace d square by minus a square, dd dash by minus ab. But in this case again that is coming 0. Because of that, the answer probably is written as this one. You can check. If you replace d square by minus a square, so it is minus 1, and d dash square by minus b square, so it is plus 1. Yes, it is coming 0. Yeah, good. So use a general method then. Use a general method to find out that solution, because you already know this. We've seen this term. General method says apply this factor d minus md dash. D minus md dash is equal to d minus md dash of fx is Is it e raised to mx integration of e raised to minus mx fx dx, something like that. So it is not only that x, it is f of x comma y. So if f of x comma y is there, we replace y by c minus mx, something like that, and dx. So something, that formula we seen, and then you have to do this. Okay, so that way you have to go there and you will get that answer. Yes, y is equal to c minus mx, correct answer. 26th, we have to solve this differential equation. Dou 2z by dou x square equal to dou 2z by dou y square. It is actually p square equal to q square, but it is a second order, so it is better you can go this way. It is not a first order PDE, so whenever higher order are there, like p square minus p square equal to q square, so you can take actually it is a d square minus d dash square is equal to 0. So d square is m square minus 1 as a 0, so m is plus or minus 1. As m is plus or minus 1, z equal to f of y plus mx, or f1 of y plus mx plus f2 of y minus mx. So that about the solution there. So that way we can get these solutions. Good, that's correct answer. This is the answer which is written correctly here. 27th solution for this differential equation. Now this is not homogeneous. This is not a homogeneous. So d is equal to m and d dash is equal to 1. Is it correct? Is it correct? Yes, anyone? 27th answer, is it correct? Is there a mistake? Yes, quick, tell me. 27th is the correct answer written. We have this one, d minus md dash minus c equal to 0. If this is the factor, then what is the yc? I think e raised to cx f of y plus mx. Is it? So for the first factor, that is correct. So f1 of, no, that is also not correct. So for first factor, one is a root, so z equal to f of y plus x. M is equal to, so sorry, y minus x, no? Tell me quickly, am I writing correct? So if you compare with d minus md dash minus c, what is the value of m? M is coming as 1. Sorry, my mistake again. Sorry, no. M is 0. For this factor, m is 0 and c is 1. M is 0 and c is 1. So what should be the first root? First term? Yes, e raised to x f of y. That's correct, Kaushik. E raised to x f of y. So that's for the first term. And what about second term? E raised to minus x f of y plus x. Okay, just 1 minute. Hello. Hello. Oh, okay. ठीक है. Okay, is it clear? Any doubt? Yes, any doubt? So the answer, as if this last question is not correct only, otherwise yes, everything is done correctly. You may have a confusion between homogeneous and non-homogeneous. Why it is a non-homogeneous? First, you should look here. You should look this equation here. This factor mainly. Yes, no issue, This is only, so correct answer is z equal to e raised to x f of y. plus e raised to minus x f of y plus x. Okay, I hope there is no doubt in up to 27 then. The last 4 questions. Okay, who completed this? So again 27th is written, no issue, probably xux plus yuy is equal to u square is a non-linear partial differential equation. Now what is a linear? The linear partial differential equation have the degree 1. Okay, so if you observe, whenever we have the linear differential equation, just to recall the definition of ordinary differential equation. So this is the dy by dx plus py equal to q. This is a linear PDE. This is a linear ordinary differential equation. Okay, linear ordinary differential equation. Why it is a linear? Because the dependent variable sorry, this is y, and its differential coefficient both occurs in first degree, and there should not be the term of y square, there should not be the term of dy by dx into y like this. So if these terms appeared, if y square term appeared or y into dy by dx appeared, it becomes a non-linear. So in this case, what is the dependent variable? The dependent variable is u, because ux is written dou u by dou x. Dou u by dou x is nothing but ux. So you should not be in the quadratic power. Okay, you should not be in quadratic power, or that u into ux should not be there together. Okay, u into ux also should not be there. So whatever the answer is written false, that's correct, because u square appeared there. Is it clear? Is it clear? This is actually a non-linear because u square is there. If suppose u square was not there, then we say it is a linear PDE. It is a linear PDE there. That's all. Second, xux plus uxx is a non-linear PDE. This is again a false, because you will observe it is a dou to u by dou x square. The degree of dou to u by, so this is the second order differential equation. This is the second order differential equation, and degree is 1. It is a linear. Power of, this is the second order, degree 1. So yes, it is a higher order differential equation, but it is a linear again. It's a linear. So it is written non-linear, so it is false. Correct. Yes, 29th. U is equal to x square minus y square is a solution of uxx plus uyy equal to 0. So just you calculate ux is coming to uyy is coming -2, and it is satisfied, so it's a true. That's correct. Okay. Next, u equal to e raised to minus t into sin x is a solution of this. So again the same thing we have to do it. Calculate dou to u by dou t square. Dou to u by dou t square will become the same, e raised to minus t sin x only, and dou to u by dou x square become a minus, and if you add it, it is coming 0. So I think it is again true. Yes, it's a true. Okay, so it is very straightforward. Just you have to substitute that value of u in the differential equation. If it satisfies the differential equation, then it is a solution. If it not satisfy, it's not a solution. That's so simple. Last question. X dou u by dou x plus t dou u by dou t is equal to 2u is the ODE. Ordinary is an ordinary differential equation. Is it ordinary? No, because it's a false. So this is not ODE form. Remember, this is not ODE form. Ordinary means there should not be a partial differential operators. Okay. So if there is a du by dx and du by dt, then it is ODE. Ordinary means, ordinary differential coefficient means which have only one independent variable, and the equation which is not ordinary, it is a partial. Am I clear? Is it clear? Okay, so
Yes, sir.
okay, so good. The answer is written correct. It is a false only. It is false, but this is not ODE form. I don't know what is written for by this ODE form. This is not a ODE form. there is by observation only we say it is not ODE because partial coefficient occurs there, so it is not ODE. That's one. Okay, so that about all the questions. Just a minute, I'll stop recording.